Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 21, Definite Integration. Last class, the integral was a whole family of curves, forever trailing up plus c. Today we pin it down between two limits, and the constant vanishes, leaving a single honest number, the signed area under the curve. The fundamental theorem links that area to the antiderivative and a handful of properties. Above all, the king property collapse fearsome-looking integrals in three clean lines, one idea at a time. Here is what you will master today. First, the definite integral as area and the fundamental theorem of calculus. Second, the properties of definite integrals. Third, the king property, replacing x by a plus b minus x. Fourth, the integral as a limit of a sum. And fifth, work problems plus the full drill suite, one idea at a time. 4 ideas. Run this entire chapter. Look at them together first. A number, not a family. The definite integral from a 2b is a single value. The signed area between the curve and the x-axis. The fundamental theorem. If capital F is any antiderivative of f, the integral equals capital F of b minus capital F of a. The plus c cancels. Properties. Swapping the limits flips the sign. You may split the interval at any point, and the king property is the crown jewel. Master line. The indefinite integral gives a family plus c. The definite integral pins two limits and returns a number. Now look at the picture. The definite integral seen as an area. The meaning. The definite integral of f from a to b is the area between the curve and the x-axis over that interval. Signed, area above the axis counts positive and area below the axis counts negative. The fundamental theorem. Evaluate an antiderivative capital F at b and at a and then subtract capital F of b minus capital F of a. The bracket. We write it as capital F of x with a vertical bar evaluated from a to b. Now the core properties, the ones the exam turns into marks. Reverse. The integral from a to b equals minus the integral from b to a. Zero width. The integral from a to a is 0, no width, no area. Additivity. Split at any point c, the integral from a to b equals the integral from a to c plus the integral from c to b. Linear. Pull constants out of the integral, and the integral of a sum is the sum of the integrals. Known as symmetry shortcuts, pure marks, if you spot them. The dummy variable. The variable is just a placeholder. The integral in x or in t gives exactly the same number. Odd, over symmetric limits, minus a to a, an odd function integrates to 0. The two halves cancel. Even. Over minus a to a, an even function gives twice the integral from 0 to a. 0 to 2a. From 0 to 2a, it is twice the 0 to a integral if f of 2a minus x equals f of x, and it is 0 if f of 2a minus x equals minus f of x. Periodic. The integral over 1/4 period is the same, no matter where you start. Now, the crown jewel, the king property. Look at the picture. The rule. The integral from a 2b of x equals the integral from a 2b of r plus b minus x. Y. Replacing x by plus b minus x reflects the curve about the midpoint of the interval, but the enclosed area is unchanged. Special case. From 0 to a, the integral of f of x equals the integral of f of minus x. The payoff. It turns a stubborn integral into a copy of itself. You add the two copies and solve. Let us watch the king collapse the classic. I equals the integral from 0 to pi by 2 of sine x over sine x plus cosine x dx. Set up. Call it I and apply the king property with a plus b equal to pi by 2. So replace x by pi by 2 minus x. Now swap. Sine becomes cosine and cosine becomes sine. The new integrand is cosine x over cosine x plus sine x. Add I plus I equals the integral of sine x plus cosine x over sine x plus cosine x, which is simply 1. So 2I equals the integral of 1 from 0 to pi by 2, which is pi by 2. Answer: I equals pi by 4. The king property collapsed it in 3 lines. Now the definition from first principles: the integral as a limit of a sum. The idea: the integral is the limit of a sum of thin rectangles as their width shrinks to 0. The formula: the integral from a 2b of f equals the limit as n goes to infinity of h times the sum of h, where h equals b minus a over n. In practice, recognize a given infinite sum as a definite integral from 0 to 1 and then simply integrate. Now match each property to its result. Reverse limits goes to minus the integral with the limit swapped. An odd function on minus a to a goes to 0. An even function on minus a to a goes to twice the integral from 0 to a. And the king goes to the integral of f of a plus b minus x. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The integral from minus 1 to 1 of x cubed dx is 0. Correct. X cubed is an odd function. Statement 2. A definite integral always carries a plus c. Wrong. It is a pure number with no constant. Statement 3. The integral from 0 to pi by 2 of sine x over sine x plus cosine x is pi by 4. Correct. That is the king. So the answer: 2 are correct. Statements 1 and 3. The trap is the phantom plus c in statement 2. Now the 2 mistakes that quietly cost marks. The truth: a definite integral is a number. No constant of integration ever appears. The trap: ignoring sign, area below the axis is negative, so the integral can be less than the total geometric area. The second truth: the king property reflects the curve about the midpoint and leaves the value unchanged. The second trap: using an antiderivative straight across a discontinuity, like 1 over x through 0, which gives a false answer. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The fundamental theorem formula: capital F of B minus capital F of A. Question 2. The integral of an odd function over minus a to a, 0. Question 3. The king property: the integral of f of x equals the integral of f of a plus b minus x. Question 4. The integral from a to a, 0. And question 5. Swap the limits. What changes? The sign. Let us gather it all in one breath. The definite integral: a number, the signed area under the curve, from a to b. The fundamental theorem: the integral from r to b of f equals capital F of b minus capital F of r, where capital F is an antiderivative. Properties: reverse flips the sign, split it c, and constants pull out. Symmetry: odd gives 0, even gives twice the half, and use periodicity. The king property: replace x by a plus b minus x, add, and solve. Next class: area under curves, the area bounded by a curve, and the area between two curves. Pin an integral between two limits, and it stops being a family of curves. It becomes a single, honest number, the signed area beneath the graph. The fundamental theorem hands you that number through the antiderivative, and the king property turns the frightening integrals into 3-line victories. Next class, we cache all of this into real area, bounded by a curve, and between two curves. Sarah, David, Lisa, and John all begin exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.